Alright, here we go. We're going to take a little bit of time to do some notes on function rules and writing a function from a pattern. So what we're going to do here is we're going to start off with some data in our XY columns, and the first thing you're going to want to do is you're going to want to find your change in X and your change in Y. So to get from 6 to 3 you have to subtract 3. To get from 0 to 1 you have to add 1. Now if you look at this, that same pattern must continue for this to be a function, and it's going to happen. Just a little proof: to get from 3 to 0 you're going to subtract 3, and to get from 1 to 2 you're going to add 1, and that has to continue for the whole table for this to be a function. So our change in Y is we're going down 3, our change in X is we're going up 1, so the rate of change is Y over X. So we have a rate of change of -3 over 1, or just -3. Our starting point is when X is equal to 0, so we just have to look at the chart and we get 0, 6. So what is our function rule? Well, our function rule is just y equals mx plus b. So y is equal to m, which is our rate of change, also known as slope, x plus our y-intercept, or our starting point of 6. So that's how you write a function rule from a table. So what I would like you to do is pause and complete number 2 on your own. Follow the same steps and we'll see if you get the same thing. So did you get the same thing that I got? Your change in y is you're going up 5, your change in x you're going up 2. So that means your rate of change is 5 over 2. Your starting point is when x is 0, so 0, 10. So then you just write your function rule and y equals mx plus b, and you get y equals 5/2 x plus 10. So moving on. Question number 3. Very similar to question number 1 and 2. Except for the fact that, well, you don't know what your starting point is. Now, what I would like you to do is just think about this for a second and see if you can tell me what your starting point would be. Okay, this is how you would do it. So still, we got to find our change in x and our change in y. So our change in y is we're going to go up 4. Our change in x, we're going to go up 1. So our slope, or our rate of change, is going to be 4 over 1, which we can just call 4. Now we have to find our starting point. Well, you kind of have to work backwards here. So we're just going to imagine that we're going to go backwards. This would be subtract 1, and we're going to get to 0. And we're going to go backwards here, so subtract 4, and we're going to get to 2. So our starting point is actually 0, 2, and you could just, look at the table and work your way backwards until you get to x equals 0. And then all you have to do is write your function rule, which is y is equal to 4x plus 2. Again, go ahead and pause the video and you try number 4 and 5 and press play when you're ready. So for number 4, did you get y is equal to 4x minus 3? If you look at your change in x, you're going up by 1. Your change in y, you're going up by 4. You do have your starting point at 0, -3, so it's just y equals 4x minus 3. And in number 5, you did have to find your rate of change, which is 1 over 1, but you had to work backwards to find your starting point, so you had to skip back 1. So you're going to have 0, -3. So your function rule is y equals x minus 3. So that's when you have, data given in a chart. Well, there's more than one way to write a function, and it doesn't always have to be from a chart. It could be from some sort of real-life example. So what we're going to do here is we're going to work with some apple trees. We're going to determine the next entries in each pattern, and then we're going to determine a function rule. So for this one, you just kind of look and see that it looks like we got day 1 we have 3 apples, day 2 we have 4 apples, day 3 we have 5. Assuming you can guess that we are going to have 6 apples on day 4, and then on day 5 you are going to have 7 apples. This is assuming that obviously none of them fall off the tree. So what you need to do to write a function rule from something like this is kind of just determine your rate of change as well, and you also have to go back to day 0 to find out what your starting point is. So the number of apples times the number of days plus, obviously, the amount of your initial apples. So we have to go backwards to day 0. And how many apples do you think you would have had back on day 0? Well, it looks like you add 1 each day. So to go backwards, we subtract 1. And that means on day 0, we would have started with 2 apples. So we take the number of apples is equal to how many, or the increase per number of days plus the original amount of apples. So it increases as 1 apple per day, and we started with 2. So to write a function rule from this, all we have to do is say y is equal to x plus 2. Or you can write it apples is equal to, 1 times the amount of days plus 2, because that's how many were on when the tree first started. Okay, and we're going to do that again, but this time we're going to do it with toothpicks and making triangles with a certain number of toothpicks. So, 1 triangle, see, we're just kind of hiding the triangles behind as they go backwards. So 2 triangles takes, you would count that, we got 6, and then it's 10. So 1 triangle, so we have 6. 2 triangles, we have 10 toothpicks. And then if we count all of these for 3 triangles, we're going to have our 6 and add another 4 to get that guy, and add 4 more to get that guy, and you've got 14. And then magically in 4 triangles, you have 18. See how quickly I drew that? So we've got 10, 14, 18. I think you get the point. We are increasing by 4 toothpicks per triangle. But then again, you have to go backwards. What if you had 0 triangles? Well, we would subtract the 4, and we would be left with an initial 2 toothpicks to start. So we're going to predict the number for 10 triangle pattern, and we can do this with concrete or develop a function rule. Well, the fastest thing is to develop a function rule. What if I asked you to predict how many toothpicks were going to be when there are 100 triangles? Have fun trying to count all those. So predict the amount. This is what we're going to do. We have our y is equal to our rate of change. It increases by 4 per triangle. And then we have our initial 2. So 10 triangles would be 10 times 4 plus 2. We're going to predict 42 toothpicks to make 10 triangles. Now in order to do that, if you want, you can just, and as we add 4, we get 10, 14, 18, 22, 26, 30, 34. See, check that out, we got it. And then we have 38 and 42. So our prediction was correct. And again, imagine if I said do 100. It would take you quite a long time to count and fill in a little chart until you get to 100. That's why developing a function rule, it will save you plenty of time. If you have any questions, you know where to find me. Have a good one.